Good morning. So today we're going to go over Unit 5, Day 4 notes, which is the last day of notes in this unit. We're going to go over arithmetic and geometric series. So last class we went over sequences, and when we add together the terms in a sequence, we form a series. So the sum of a series results when terms are added. We can write this in sigma notation, which is a sigma, which means sum. I'm going to use like U sub r because we have U sub n right here. So I'm going to say U sub r. We could actually use anything right here. But we're going to go as r goes from 1 to n because we are ending with U sub n. And we'll just put an n on top. And so we're going to think of r as our counter, and this is the sum of the first n terms. So I'm going to write that there. The sum of the first n terms. And we read this as the sum of all numbers of the form U sub r, where r is equal to, and then we go from 1, 2, 3, and we go all the way to n, whatever we decide to put as our n. For the sequence 1, 4, 9, 16, 25, write down an expression for S sub n using sigma notation. Well, 1 squared is 1, 2 squared is 4, 3 squared is 9. So it looks like S sub n is equal to 1 squared plus 2 squared plus 3 squared plus 4 squared. Ooh, 5 squared is 25. Okay. And then we're going to go all the way until we decide whatever they decide for n, and that's going to be n squared because that fits the pattern. I can write this as a sigma notation, which is what they want. So the sum, as r goes from 1 to n, we don't know where we're going to end yet, of r squared. And this is S sub n. This is the same thing as the top line. These two are the same. Now, find S sub 5. All we have to do is plug them in. So we have to plug in 1, 2, 3, 4, and then 5. So S sub 5, this is a 5 now, equals 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. I would, so this is 25 plus 16 plus 9 plus 4 plus 1. I think that's 55. Check. Make sure. Alrighty. So go ahead and, well, let's just go down. So consider the arithmetic sequence. I'm going to fill this in, and I'll show you the proof in a second. Alrighty, let me just go over this real quick. So if we have our S sub n, the sum of our sequence, or the sum of our series, which is a sequence, is our initial term plus the initial plus the difference, right? When we have arithmetic, we have a difference. And then the third term is our initial plus 2 times our difference. We learned this last class. And if this is our U sub n, we have to subtract the difference to get the one before, and then subtract it again to get the one before that. And what they did on the second S sub n, it's the same thing, except we flipped it. So this is just flipped. So instead of ending with U sub n, we put it in front, and then U sub n minus d, we put that second, and then this one goes here, and then this one goes here, and then we did this. And then what we did to prove this is we just added them. S sub n plus S sub n is 2 times S sub n equals, and then when we add this, U sub 1 plus U sub n plus, when we add these, the difference, the d's go away, and we still have u sub 1 plus u sub n. And then when we add these to 2d plus negative 2d, these go away, and then these d's go away, and they're all u sub 1 plus u sub n, all of them. And this is n times. So this is how many terms there are n terms, or n of these. So when we condense that, remember that's how we multiply. So we have n times u sub 1 plus u sub n. And we have that's equal to 2 times s sub n. Now, what they did is they expanded this. This is equal to n times u sub 1 plus, and this can be written as u sub 1 plus n minus 1 times d, and this is equal to n times, I'll just use a different color. So I see this is 2u sub 1 plus n minus 1 times d. And that kind of gets us to our formula. If we divide by this 2 on the right-hand side on both sides, then we get s sub n equals n over 2, parentheses, u sub 1 plus u sub n, or we have s sub n equals n over 2. We need both. Oops, n over 2 times 2u sub 1 plus n minus 1 times d. So these are the two formulas that we can use. Now these are very important, so write them down somewhere where you can have like a little cheat sheet. What is the sum of 3 plus 7 plus 11 all the way to 20 terms? So my n is 20. I need my difference. So 3 to 7 is 4, and then 7 to 11 is 4. Good. So my difference is 4. And I need my u sub 1, my initial term. So my initial term is 3. And I can use our formula, which is s sub 20 equals n over 2, so 20 over 2. I'm just going to fill it out first, and then we'll simplify it, times, I don't know my last term, so I'm actually going to use this formula. 2 times my initial, which is 3, plus n minus 1, which is 20 minus 1, times my difference, which is 4. Alrighty, you can actually just put this in the calculator. I know that 20 over 2 is 10, and then this is 6 plus 76 equals maybe 80. So 82, so 820. Alrighty. Go ahead and flip your paper over, and let's try a couple of examples. So I just wanted to read this. It says a pyramid has logs, 2 logs on the top row. So there's like 2 right here, 4 logs on the second row, 4 right here, then 6 logs on the third row, and so on until there are 200 logs on the bottom row. So they're actually giving you your u sub n. So we can use the first formula maybe. So it says u sub n equals 200, right? What is the total number of rows? That is our n. So we don't know what n equals. That's going to be our x, or our variable. So our formula is u sub n, or the sum, 200 equals my initial, so this is u sub 1, my initial is 2, and then we have n minus 1, I don't know what n is, times the difference. And it looks like it is arithmetic because 2 to 4 is 2. And 4 to 6 is also plus 2. So it does look like it's arithmetic. Sorry, this is 2. Okay. We have everything we need to fill this out. We just have to distribute our 2. And we're going to get 200 equals 2 plus 2n minus 2. The 2's will cancel, and we'll get 2n equals 200. Divide by 2, n equals 100. So this is how many rows there are. There are 100 rows of logs. So it says, what is the common difference? I did that. What is the formula for the nth term of the sequence? So u sub n, which we found, is u sub 1 plus n minus d, or n minus 1 times d. And I'm just going to plug it in. The first term is 2, so u sub n equals 2 plus, and we can say n minus 1 times 2, and we can actually distribute our 2 to both. 2 plus 2n minus 2, which is equal to 2n. How many logs are in the 76th row? And this is why they asked us for this. So in the 76th row, this is our formula. U sub 76 equals 2 times 76. We figured that out right here. This, I think, is 152 logs in this row. How many logs are in the first 12 rows? So the first 12 means they want us to add them together. So the sum of the first 12 equals, I think this one was n over 2, so 12 over 2, parentheses. I just wrote down the formula. I know I need this one because I don't know my u sub n term. I don't know the term in the 12th row. So we have 12 n over 2 times 2 times my initial term. I know my initial term is 2 logs on the top row, plus n minus 1, so 12 minus 1, and then times my difference I know is 2 from up here. So my difference is 2, like this. 12 over 2 is 6, and this is 11 times 2, which is 22 times 4, or plus 4. I think this is 156. Try it, make sure. Logs on the 12th row, or the first 12 rows have 156 logs. So we're going to also do the sum of geometric series. It says, consider the geometric sequence and our S sub n, or the sum of the geometric series. We're not going to worry about the proof. S sub n is u sub 1, the initial term, times the ratio to the nth power minus 1 over r minus 1. The ratio minus 1. We also have another formula for this one, which is S sub n equals u sub 1 times 1 minus r to the n over 1 minus r. Same formula, just we switch these. Alrighty, r cannot equal 1. That would be dividing by 0. That's not a thing. Find the sum of the series, and we know that this is going to be a geometric series. What am I going to multiply by to get from 6 to negative 3, and from negative 3 to 1.5? I know my initial term is 6, so my u sub 1 equals 6, but my r is a second term divided by the first term, or negative 3 divided by 6, or negative 1/2. And that works for the second two, and it works for these also. Okay, good. So negative 1/2 is my ratio. I'm going to just plug this one in. So I'm going to try this one. So we have S sub the 15 terms. So the first 15 terms. S sub 15 equals the initial, which is 6, parentheses, 1 minus negative 1/2 to the n, 15. Can you guys see that? Over 1 minus, r is negative 1/2. Alrighty, I want you to just plug that into your calculator, and I think we're going to get something like 4. Round it. That's S sub 15. Find the sum of the series to 12 terms. So the first 12 terms. So my u sub 1 equals the first one, which is the square root of 7. My ratio is the second one over the first one, which is 7 over the square root of 7. I would like to rationalize this denominator. So multiply the top and the bottom by the square root of 7. So this is actually just square root of 7. So I'll show you. 7 square root of 7 is 7 square root of 7. We cannot multiply those. Divided by, this is now 7, so the 7s will cancel. It's equal to 1. Anything over itself is 1. So I'm just given the square root of 7. It's my ratio. Or the square root of 7 over 1, if you would like that. My n is going to be 12. They want to the first 12 terms. Add up the first 12 terms. So n equals 12. I'm just going to plug it into the formula. S sub n, or S sub 12, equals my first term, which is the square root of 7, parentheses 1 minus the square root of 7 to the 12th power, all over 1 minus the square root of 7. Plug that into your calculator. We're going to get something like 189,133.89. Try it on your own. Okay, list the first 3 terms and the last. Find the sum of this geometric series. So in order to find the sum, we need the first term, we need the ratio, and we need how many there are in the series. So it looks like there are 12. My n equals 12. So we're going to do S sub 12. My first term, u sub 1, equals, when I plug 1 into here, 1 minus 2 is negative 1. So this is 1/2 to the negative 1, which means that we just need to flip the fraction, which is 2 to the positive, or to the 1 power, which is 2. So u sub 1 is 2. 1 minus my ratio is going to be 1/2. So what we can do is find u sub 2 and make our fraction to make sure. So when we plug in 2 here, this is going to be to the 0 power, and anything to the 0 power is 1. So this equals 1. U sub 2 is 1. And my ratio is the second term over my first term, which is 1/2. So we have 1/2 to the 12th power, because we want the first 12 terms, divided by 1 minus 1/2. And we can just plug this into the calculator. This equals probably like 3.99, but it keeps going, so we're going to say 4.0. 2 decimal spots. It says list the first 3 terms and the last term, so you guys can do that. The first 3, my last one is 12, plug in 12. Alrighty, let's take a look at another example. Okay, so it says, consider the story of Sisa. Sisa was a famous mathematician. He lived in India and he taught his king about chess, a game called chess. And the king was so happy that he offered Sisa anything that he wanted. And Sisa said that what I want as payment was he said, put 1 grain of wheat on the first square of the chessboard, 2 grains of wheat on the second square, 4 grains on the third square, 8 grains on the fourth square, and so on. So we're doubling the number of grains of wheat with each square of the chessboard. So I'm going to write this down. We're going to do 1 grain of wheat on the first one, and then 2 grains, and then we're going to double it. So 4 grains, and then 8 grains on the fourth square. Okay. And, the king was like, oh, what a dummy. And then he couldn't deliver because we're going to find out how much grains the king would have had to pay. So I think there are 64 squares on a chessboard. So n equals 64. And this is geometric because we're doubling it each time. So we have the sum of, we're going to say 2 to the r minus 1 because our ratio is equal to 2. 2 over 1 is 2. And our u sub 1 equals 1. So this is going to be the summation as r goes from 1 to 64 because there's 64 squares on a chessboard. So if we wanted to calculate the total number of grain or wheat this king would have had to pay, S sub 64 is the initial times 1 minus 2 to the 64 over 1 minus 2, the ratio. Alrighty, if you put this into the calculator, it's a big number, okay? I think my calculator does it in like scientific notation because it's so big. 1.845 times 10 to the 19 grains of rice. I encourage you to look this up. It's pretty cool. So the sum of an infinite geometric series, if we're trying to add up an infinite amount of boxes, some people are like, hey, that's going to be infinity. Not always. So what is the total area of shaded boxes as a number of boxes approaches infinity? Well, this area is base times height, which is 1/2 times 1/2, which is 1/4. This area is 1/4 times 1/4, which is 1 over 16. This area is 1 over 8 times 1 over 8, which is 1 over 64. So remember, we can find our ratio by dividing 1 over 16 divided by 1 over 4. And you're going to multiply by the reciprocal when we have fractions. So my u sub 1 equals 1 over 4. But my ratio is also 1 over 4. Alrighty, so my s sub infinity, we're going to go from 1 to infinity, is 1 over 4. 1 minus 1 over 4 to the infinity. Let's find out what this is. That's different. All over 1 minus 1 over 4. Alrighty. So as we have 1 over 4 to infinity, this approaches 0. If the denominator is bigger than the numerator, then it's going to approach 0. So I'm going to make a little note for this. This approaches 0. Just this term right here. So if we simplify this, this is going to be 1 minus 0, which is 1, times 1/4, which is 1/4, over 1 minus 1/4, I think, is 3/4. Remember, we multiply by the reciprocal, so we're going to get something like 1/3. Now, we can only find the sum of an infinite series if my numbers decrease or if they converge to a number. We see that n approaches infinity, or as n gets very large, a series either diverges if r is greater than 1, or converges, which is what we want, if my ratio, if the absolute value of my ratio is less than 1. And this is really what we want in order to find the infinite series. Otherwise, it's just infinity. So S sub infinity is the initial always over 1 minus r. Pretty much always. This works out. If r is less than 1. The absolute value of r is less than 1 if it converges. So we can do this. It says find the infinite geometric series, or find the sum of this infinite geometric series. So I need my ratio. My u sub 1 is pretty easy. This is 2/3. But I need my ratio. My ratio is -4/9 over 2/3. Remember, we multiplied it by the reciprocal, and we're going to get my ratio equals maybe 2/3? -2/3? Okay, I just wanted to make sure. So my ratio is -2/3, but the absolute value of -2/3, ooh, that is less than 1. So it does converge. Therefore, it converges. And we can use our formula. So my S sub infinity equals my initial, which is 2/3 over, and then 1 minus r. So 1 minus -2/3. That's okay. This is 2/3. So this is 3/3. This would be divided by 5/3, I think. Multiplied by the reciprocal, we get 2/5. The 3's will cancel. So 2/5. And it's positive. I want you guys to try the other ones. Remember to use the formula, and it only works if your series converges. Have a wonderful day.